Hi everyone. Um, we've started the quadratics topic now, which you should be familiar with, but we can go through it in a little bit more detail and use the graphics calculator a little bit more. The situation is a good one, so if you haven't done it already, have a go, and then I'll go through the solution in a second. Okay, let's have a look at this case. We've got a sawtooth pattern that's being cut by a machine out of a 16 by 10 centimeter sheet. The first cut is made with the equation y equals x squared from 0 to 2, which is this portion here. I've graphed it down the bottom here. Oh, no, I haven't graphed it. To complete the cut requires a series of transformations. So we need to, for the second cut, have a transformation where the graph's been moved across a little bit, and it'll make that one, and then move it across a little bit more, and then make this one, and move it across a little bit more, make that one, and then move it across and finish off the last step. So I've put the transformations in here so that I could draw the sawtooth on the CAS calculator, and you'll note that I'm putting the ranges here on the right hand side. So x take 4, moving it 4 across, then x take 8, moving it another 4 across, x take 12, moving another 4 across, x take 16, moving it another 4 across. And in each case I've used turning point mode, turning point form to graph the equation. Now, the second sawtooth has a slightly different shape. It has our y equals x squared equation here, but then it has a second quadratic equation that's been moved up as well. And you'll see it's got a part on the end. So this one here, not only has it been moved 3 across, it's also been moved 3 up. 3 across and 3 up. That gives us the short one. Then we do another big one, which doesn't have any vertical shift, which would be x take 6. And then x take 9 plus 3 would be this part, with a turning point of positive 9, 3. And so on and so forth. And if we do all of these equations here, with these ranges, we will get that sawtooth pattern up there. And thus we can satisfy the situation. Let's look at quadratic functions in more detail. So a quadratic function is a polynomial function of degree 2. Degree is the highest non-zero power in the polynomial, which in this case is x squared. A can't be 0. I suppose I could write that on here. Now, there are 3 common forms of a quadratic equation. There's standard form, in the form y equals ax squared plus bx plus c. That's the normal polynomial form. There's factored form, where we've factored it into 2 brackets and had some sort of amplitude up front. It's not really an amplitude, it's a dilation. And then turning point form, where p and q represent this point here on the quadratic, and x equals p is the line of symmetry. Something to note is that when a is greater than 0, the graph is concave up, it's like a bowl. And when a is less than 0, it's concave down, and it would have been this way, like an upside down bowl. With factored form, h and k represent the x coordinates where it either touches or crosses the x-axis. So in this case, this isn't a particularly good case. We'll look at a case a bit later on about it. In standard form, this c over here is the y-intercept. So this form, good for finding the y-intercept and the concavity or the nature of the function. This one, good for finding x-intercepts or roots, and you can still look at the concavity with a, and the direction of the curve. And turning point form, good for finding the turning point and the line of symmetry. We can do some of these things with the other functions, but these are the most obvious things that you can take out of each form. Okay, turning point form. Let's look at that one first. and how transformations apply to turning point form. Given the function f of x equals x squared, if we want to translate it 2 units to the left, that's x plus 2, 2 units to the right, be x take 2. 2 units up, add 2 to the function, 2 units down, subtract 2 from the function. So if we're looking at the transformation from y equals x squared to 2 units on the left, it would be y equals x plus 2 squared, so on and so forth. If we want to dilate the function by a factor of 2, dilate it to y, which will make it thinner, we multiply the function by 2. That will give us 2x squared. If we want to make it wider, we would halve the function, and it will move the curve away from the y-axis. If we want to reflect it across the x-axis, we find negative f of x, which is negative x squared. And if we're looking at this function here and we wanted to compare it to y equals x squared, this function has been moved. What? Oh, okay, let me start again. What we're saying is that f of x is 2x squared plus 1. If we want to move this function 2 units up and 3 left, we would do this to it. Wherever we've got x, we're going to change it into x plus 3, and then we're going to put 2 on the end of the function. So here we are, we've put x plus 3 where x was, and there's the function bit that was there from before, and we want to add 2 to it. There it is there. So if we move this function 2 units up and 3 left, we will get this function here, 2 brackets x plus 3, all squared plus 3. If we wanted to reflect this function parallel to y, we would put negative outside of it, which will give us negative 2x squared take 1. If a function is concave down in this direction, it will have a maximum turning point. And if it is concave up, like a bowl, it will have a minimum turning point. Turning points, other than in turning point form, can be a little bit difficult to find, and there are some tricks to finding them. When we do some calculus, we'll have some ways of doing it a little bit easier. Something to note, that when you're doing quadratics, you want to put powers to x quite often. On a CAS calculator, we use the caret symbol. It's on the keypad. Let's see if we can find it. There is a way of getting up in the other form. Where is it here? Oh, I can't remember how to do it. Keyboard. Is there a caret symbol here somewhere? No. Anyhow, not very important. One thing to note though is if you're trying to do x to the power of 2a plus b, make sure you put this brackets in, or it will do this instead, which would be y equals x to the power of 2a plus b, which is different to what was being attempted, which is y equals x to a plus b. So be careful with that. It's a common calculator mistake, calculator error. All right, let's go through some CAS calculator usage. One really nifty thing you can do with your CAS calculator is to set up a function. So I'll just do that here. Interactive, define f of x equals, we were using 2x plus 1 before, weren't we? Plus q, 2x plus 1. There we go. So I've defined a function now. I can graph that function. I might just set up a range for this function. The easiest way to do that. Oh, I know, we'll just graph it. Just graph it. And then we will quick standard. There we go. So we have this function y equals f of x. Now, if we wanted to move it up one, we could just do f of x plus 1, and then graph y, and there it is, just been moved up by 1 unit. If we want to move it to the left by 1 unit, there we go. It's gone from here to here. Gone left 1 unit. If we want to move it right 1 unit, there we go. If we wanted to make it steeper, there it is. Want to make the graph shallower, or dilate it away from y. There you go. And I think that's the full range of dilations in translation. So we want to reflect it. Okay, let's reflect it. So there you go. So instead of being up here, it's now reflected across the parallel to the x-axis, so it's now here. Here, it's now down there. Down here, it's now up there, so on and so forth. One thing to note with functions defined in the calculator, and I've done lots of quadratics here with the same sort of operations here, is to clear all your variables when you finish so you don't leave the function in the calculator, and it could cause problems with you when you're doing other work. So to do that, you go into main mode, edit, clear all variables. Now if I type f of x, it won't do anything. Didn't. Weird. Oh, yeah, because I've still got it there. Clear all. Clear all variables. F of x. I always thought that cleared it. Obviously it doesn't. Be careful of it. If you redefine it, it'll define over the top. And there you go. I think that's all for this little section. Thank you.